Hello, my friends of Hateri Labs. Welcome to this webinar. And in this webinar, we are going to work with the simulation of tidal, um, of aquifer, of coastal aquifers with tidal water level response. Okay. So, what is the topic about tidal water level response? Is that in order to simulate the tides, we have to use lots of stress periods, and this is a challenge when we use software like ModelMuse or any other software because like every stress period has to be inserted in a certain way. Okay, so let's see, you have in the description of the video, you have, okay, let me, okay, in the description of the video, you have this folder, and in this folder you have a model1.gpt. Okay, so just open the model1.gpt, please. Okay, so here we have um, a model that in model muse. Okay, and in this model we have a coastal aquifer, so this is a general head boundary. The model has evapotranspiration, has recharge, has a river, and has some wells. Okay, great. So the model has evapotranspiration, has general head boundary, that is the sea, has recharge, has a river. Okay, and there are some wells. Great, and there are some observation points as well here. Great. Okay, so here we have our observation points. Great. So what else? What we have here in time is that we have two stress periods, so we have a steady state and a transient. Okay, if you are here with me, please type 2. If you are here with me, please type 2. Okay, Luis, Bron, Mar, Lester, Victor. Okay, great. So we type okay. So, okay, so what I have, okay, what I have, great, is here on the txt we have the tides, okay, of 10 days of tides. I think that this is one. Okay, so and then we have, okay, we could have it with dates. Okay, there is no problem, I mean with daytime. Okay, in this case it's just 0 because 0 is the 0 seconds from the oil muse. Okay, and then here we have till this, that is 10 days of records. Okay, and then here this is the water level, okay, in meters. Okay, great. So as you see, we have lots of data. Okay, and then we want to compile all of this data, okay, into the model. So and then the solution will be to insert maybe 300 stress periods. Okay, so here you will see 300 stress period and insert 300 levels on the general head boundary. Okay, fortunately, okay, there is a way to do it in Modflow 6 because Modflow 6 inserts the time series. And what is the time series? The time series is a file where you can store the value for a certain boundary condition, but in this file, okay, you can insert like any record that you, I mean, any amount of record that you want, okay, as long as it's in the, okay, and it doesn't have to finish at the end of the model. I mean, it can finish later on, okay, but what is more important here, okay, is that these values will be interpolated to the stress periods, okay. In this case, we have two, but actually we are going to have a lot. Okay, so we are going to use the model from Model Muse in order to implement this high amount of stress periods, and with the time series, it will interpolate all of the records to those stress periods. If you are here with me, if you have understood this, please type 3. You can open your mic and do your questions if you want. Okay, great. So let's run the model. Mhm. And why we have to run the model? Because the model that I gave you was just this GPT, so you have to generate all the Modflow files. Okay, that's great. And well, you can always have a look on the water balance. Oops. Mhm. This is the MFSIM. No, I want the model one.list. Okay, and here we have the storage that is going mostly from the GHB, the evapotrans. Ah, oh, 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 yeah. If you see there is no evapotranspiration here, and that is right, there is no evapotranspiration. Why there is no evapotranspiration? Because here, yeah, here there is only recharge. And why I have, I mean, on purpose, I have done this. And why I have done this on purpose? Okay, because there is an issue with evapotranspiration when you import that in Flowpy. I mean, I found that issue and I didn't want to. I mean, for a project, I have took it out and on the Flowpy library, okay, but for, I mean, for this case, I actually haven't. I just have blocked this boundary condition. Okay, great. So, okay, so this is the boundary. Okay, so the main input here is the river and as well as the recharge. Okay, great, great. Wait. Uh, just one sec. Sí, señora Ana. Uh, wait. Okay, so we are going to start with anaconda, cd. Okay, there is some more people that want to. Okay, okay, cd documents. Okay, because documents. Okay, cd webinar. Okay, and here we are going to launch Jupyter Lab. Okay, here we are going to launch Jupyter Lab. If you are here with me, please type 4. If you are here with me, please type 4. Okay, it is, I mean, please place the zipped folder under documents, okay, because otherwise you are not going to fulfill this. Okay, yes, great. So let's see here. This is our Jupyter Lab. Okay, great. Okay, great, great. So we go to scripts and then we are going to do a new notebook that is called webinar. Webinar. Okay, great. So we have a webinar. Okay, so okay, so we are going to do our scripting in Flowpipe. Okay, first, what we are going to do is we are going to say import OS sys copy. Okay, import mat. Maybe you want a little bit bigger. Okay, matplotlib as npl. Import matplotlib pyplot as plt. Import numpy as np. Import pandas as pd. Import flowpy. Okay, so here we have all the libraries that we are going to do. Okay, and my suggestion is that always you have to change. Okay, you have to change the folder because this is the original folder, and then we have to do a copy of that. Okay, why we have to do a copy of that? Because sometimes, I mean, when you work, you actually, or you make changes, you actually are going to make changes to this model. Okay, but in case that you, I mean, that you don't want, I mean, that you want to do another changes, your model, your original model will have be already changed. Okay, so there is no way that you can go back to the original if you are working in the same model. If you have understood this, please type 4. It's 5. Okay, great. So now we are going to open the model. So we are going to workspace, and this is OS path. We use, I mean, we can define the path we can define the path um, with just these relative paths. Okay. However, sometimes there is this issue of that, especially in Windows, that they do not that Flowpy do not find the folder. Okay, and in order to omit that, we use the OS libraries. Okay, to define the total path. Okay, based on this relative path. Okay, is equal to flowpy.mf6 dot mf simulation dot load, okay, of mf sim, okay. So we are okay, we have opened the location, we have opened the simulation, okay, that is in this workspace, okay, and then sim, okay, and then we change this the sim path, okay, we change the sim path to mf6 model with time series, okay, great, okay, and then we provide the executable name, okay, and this is really tricky. Okay, so do you have like me, do you have like me your C W app, and here do you have the mf6.x? ¿Dónde está? The mf6.x, do you have like that? Okay, or if you don't have like that, please tell me the path that you where you have, okay? Please tell me through the chat. Okay, please tell me through the chat. Because this is the location of the path, this is, should be the location of the path of the your model muse of the model muse mf6. Okay, please tell me if hello. Okay, so in my case, okay, my executable will be like this. Okay, this is in my case. Okay, so it's C, and in Windows is double slash VRD app mf6.x, but that could vary based on the or how do you have installed model muse. Okay, that could vary. Okay, if you are here with me, please type 6. Victor, I'm talking about the executable of mf6. Okay, if you are here with me, please, this can vary to your own to the location of the mf6. Okay, if you are here with me, please type 6. If you are here with me, please type 6. Okay, great. Okay, so we run this. Nothing will happen because what we have open and then we define something, but actually no, nothing will be generated till we actually save the simulation. Okay, so here this is set impact. Wait. Okay, so we can look for the time units. Okay, sim dot tdis dot time units. Okay, and then we are working in seconds. Okay, and this. Okay, however, okay, we know that there are two. Okay, there is a Victor that say he has MF6.1, MF6.3. Okay, just Victor, go to the latest version. of mx6. Okay. Okay, so here we have okay. So what we are going to model is 2 days. Okay, so we are going to override, okay, the stress periods of the original model. Okay, so say total time is equal to 2 times 800 or 3600. Okay, and then say, and the discretization time will be 3. Okay, so because I want to simulate 2 times and the every time steps will be every hour. Okay, so this is a really arbitrary, because if you change that, I mean, the model will be regenerated, but with maybe you will can run for 4 days, or you can evaluate every 2 hours. Okay, that is really up to you. So the number of stress periods is equal to total time, okay, the integer of this time plus 1. Okay, because 1 is from the stress period, and so the number of stress period, the disk time. Okay, great. If you are here with me, please type 7. Okay, there is a question from the operator. Okay, and great. So what does it mean, the operator? So let's see, for example, let's see total time divided by this time is 48. Okay, but let's see that total time plus 1. Okay, so total time plus 1 is something with this. Okay, so if I want just the integral part of this division, okay, is 48. Okay, so and then if I want the rest, the decimal part of this division is, no, this is the rest. I mean, this is what is left. Okay, so this is the meaning of the double slash operator. Okay, is that understood, Luis? Sí. Okay, great. So let's see, okay, so let's work in the stress period data. Okay, so because we are going to do a lot of stress periods, okay, a lot, we are going to do a whole set. I mean, we are going to do 49 stress periods. Okay, so let's see. T, Tdis per data is equal to, let's start with the 1.0, 1, 1.0. So this is the first stress period has a length of 1 second and is divided in just one time step, and the multiplier is 1 plus, okay, and then we are going to do a least comprehension, okay, of stress period of the duration of 1 hour, or one hour, one time step, and they have a multiplier of 1. Okay, for E in range the ampere minus 1, because ampere has already the steady state. Okay, that is great. And then say length of teddies per data. Okay, so we have already the teddies per data is okay, is this list of stress periods, okay, that we are going to implement here. Okay, amazing. Okay, if you are here with me, please type 8. If you are here with me, please type 8. So, okay, so we are going to implement a lot. We are going to implement lots of stress periods. Okay, so and sim.tdis.ampere is equal to ampere. So we apply this to our simulation. So we are going to change the ampere with the new number of periods. Okay, and then we are going to also change the tdis.period data to tdis.per data. Okay, and then we are going to change as well the period data. Great, if you are here with me, please type 9. Okay, great, 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 great. Okay, so let's continue. Okay, so if you remember in Modflow 6, the stress period is related to the stress period is related to the simulation. Okay, and now we are going to work with the model. So for that, we have GBWF is equal to sim.getModel. Okay, GHB is equal to gbwf.getPackage of GHB. Okay, so and GHB is equal to, so we are going to call the stress period data.array. Okay, so this is the stress period of the general head. I mean, because the tides will be implemented in the general head. And what we find here, okay, what we find here is a rec array. Okay, so this is a rec array, and this is for the first. This is for the first stress period. Okay, and okay, so okay, if you're here with me, please type 1. Okay, so please hear, please listen. In order to implement, a time series, okay, we have to give this value will be related, this nickname, okay, because this is the head, okay, will be related to a nickname, I mean to a code, to a template name, something like that. Okay, so and this for our case will be called tides. Okay, so I don't know how to do that on the rec array, but what I know is how to do that in pandas. So we are going to change this rec array to pandas. Okay, and then we are going to change this with the nickname tides, that where the tide value will be related to the values that are stored on a text file. Okay, if you have understood this, please type 2. This is the key of what we are going to do. If you have any questions, let me know, because this happened in my mind and I did this example. Um, I know that you might have some questions. You are doing some research, something like that. That could enrich this discussion. Okay, great. So let's see. So let's say we have a rec array df is equal to pd dot data frame from records Okay, so with that, with data frame from records, we copy from the stress period. Okay, okay, from the rec array, we copy from that. Okay, and say set index cell ID. Okay, so rec array df object is equal to types rec array df is equal to. Okay, and then we do a copy because we are going to reinsert. Okay, okay. Victor, what I can repeat again? So the which step? Okay, well, I suppose this one. Okay, so this is the rec array, and then we are going to implement a time series. Time series is something new in Modflow 6. In the time series, you can relate, okay, that instead of having values, okay, is that instead of having values here, okay, you can use a nickname that will be related to values that are stored in the values that are stored in a text file. Okay, and this is handy because we only have to define, I mean, for this case, we only have to define the record rate on the first stress period of whatever happens in the future in this, whatever file happens in the future of this stress period, okay, will be related to the values on a text file. Okay, so and then since this is a rec array, we can't change or I don't know how to change this value for a text for a text, okay, but I know how can I change it in Panda, so that is why here bhead will be tights, okay, that is the nickname, okay, and then we do a copy because since we are going to insert this again in ModelMuse, so you will have a circular reference problem, so that is why we do a copy, okay, and by doing a copy, uh, we can reinsert that, okay, without these warnings on, okay, if these warnings come of circular reference, okay, this is because of the inheritance of Modflow of Python reg array df dot to record. Okay, so we say okay, and with the with when the Panda data frame you use two records, you actually change from the Panda data frame to a rec array. Okay, new rec array is okay, great. So now we have this rec array that instead of having 0 will have tights. Okay, if you are here with me, please type 3. Okay, great. So now we are going to define the max bound, okay, that is the amount of cells, okay, that it will be the same, but let's define max bound is equal to copy dot copy, okay. I use copy because otherwise I will since I will reinsert those values in the model, I could face some circular reference problems. Max bound data, so max bound. Max bound is max bound is this amount of cells. Okay, and now we are what we are going to do is that we are going to remove the original general head, okay, because we are going to remove the original head because we are going to create a new one that will have the time series, okay. So, and this Flopy allows you to remove a package and then to insert a new one. So gwf dot remove package of GHB. Okay, we remove that, okay, and then we create that again. GHB period. Okay. GHB period 0 is equal to new rec array, and GHB is equal to flowpy dot mf6 dot modflow general GHB. Okay, so we create the package for the GWF model that will have the name of the GHB. This is will be called, okay, so it will print input true. Well, so these are conditions, just print flows through. Say flows through. Bound names is equal to true as well. And the max bound is equal to max bound. And the stress period data is equal to EHB period. Okay, so with that we have created our we have created a data frame, but now what we are going to do is that we are going to then we are going to there is a there is Matt Daniel tells me that I can do this. Okay, so I will sorry, yeah, okay, I will put it, well, you can try it because yeah, you can try with something like that instead of going to pandas. You can do it this directly in rec array. Okay, yeah, you can try it. I will have to run all my cells. Thank you, Daniel. Mart, thank you, Mart. Okay, great. So let's open, and then we are going to open the type file. The type file is a text file, and well, if I can store that, and for me it will be better to store that as an numpy array, okay, NPY, okay. However, for purpose of this, is stored on the tiles on the text file. But the what is the problem here of the tile file of the text file is that we have to rec array. Okay, so we open and close, and for line inside the file, 2 points, line list is equal to line dot strip dot split. Okay, apostrophe. Okay, ts dot rec array dot append of float of line list 0. Okay, float of line list 1. Okay, and let's see ts rec array. Okay, with that we have open. Yeah, for example here these are the first 5 values. Okay, if you see we have, for example, for the interval, for the first interval we have 1 value. Okay, for the second interval maybe we have 2 values. Okay, and that is all right. Why this is all right? Because it will interpolate in between those 2 values to give 1 value to the stress period. If you have understood this, please type 4. Wait, wait. Okay, so okay, great. So, okay, so we can initialize. Okay, so we are going to initialize. Okay, what we are going to initialize, we are going to join the text file, okay, the values of the types, and then we are going to join that to the general head. Okay, so initialize. Okay, okay, so file name. Okay, file name is where the values will be stored. Okay, on the simulation. Types.ts. Okay, time series, it will be the ts.rec array. Okay, time series name record. Okay, and this is, it will be types. Okay, so this is the name record. I mean the nickname will be types. Okay, so it will say that the rec array will be applied to this. Okay, so it will be replaced here as for all the stress periods. Okay, great. Interpolation method record, it will be linear. Okay, great. So now we have, okay, so, and then you will ask me, hey, Saul, what will happen to the other boundary conditions? Okay, in Modflow, if you don't explicitly, okay, because if you don't explicitly change the boundary condition for us, because at the beginning you have data for 2 boundary conditions. For example, let's see for the river. So let's open the river package. Okay, so we have for the period 1 and Okay, so we only have for the period one. So what does it mean? That we don't have for the next periods, okay, or for example the well, we have for the period one and for the period two. So, and what does it mean that I mean that if we have 49 stress periods, actually we don't have values for the period one or the period two? No, it doesn't mean that. Okay, what it means is that the last defined stress period will be repeated over the remaining ones. Okay, so for example, if you have data for the stress period 1 and the stress period 2, and then you have 48 stress periods, okay, so it will repeat the data for the stress period 2. If it's understood, please type 5. Okay, great. That is amazing. So we can sim.write simulation. Okay, so we can write our simulation. Okay, great. And then we can run our simulation, sim.run simulation. Let's see that we have done it. Mhm. Okay, it's running. Great. If you are here with me, please type 6. Okay, great. So it's running. One is has finished running. Please type 7. If it has finished for you, please type 7. Okay. Does it finish for you? Please type 7. 7. Okay, so it has finished for me. I want to see if this has if you have finished. Okay, okay. Okay, if you are following like Vitor, also type 7 because I want to know if you are here or whether you got. Well, yeah, no, I mean it's important. Otherwise, I mean I feel kind of lonely. Okay, great. So, okay, so well, let's see. Let's let's look at our data. Okay, because we have to, okay, so this is head is equal to gwf dot output dot head. So this is a get all data minus 10 np dot percentile of head of 0. And then we have to look for, this is the, why we use this? No, just to show you. Sorry. This was just to, for my, I did that for, just to have a, just to do my own. So let's see, fig AX is equal to, uh, wait a little bit, wait a little bit. Okay, so let's see the, um, let's see the fig AX is equal to PLT dot subplots, okay, of fig size is equal to 12,8, subplot no is equal to dict of box post aspect is equal to 1, okay, and they say PMV is equal to flowpy dot plot map view of the model GWF on the AX is equal to AX, okay, and PLT, um, okay, so heads is equal to GWF dot output. We use the output of the model, so, and this is get heads get all data of the last stress period, okay, and then let's see what happens when we use PLT show, and then okay, let's see what happens here, okay, nothing because both aspect, okay, okay, so let's continue both aspect, okay, great, so let's see what happens, GWF, okay. Okay, nothing happens because actually we have just defined the box, but not the, okay, so let's see, heads is equal to np where heads is equal to 1 e to the 30 np none heads. Okay, vmin is equal to, okay, so we do some filters, okay, and then we got the np now min the heads, and vmax is equal to np now max the heads, okay, and then see pc is equal to pmv plot array of heads vmin is equal to vmin, vmax is equal to vmax, okay. Great. So this is the distribution for the last stress period, okay. Well, if you want to fancy around, you can pmv is equal to, we can plot bc well and pmv dot plot bc bc river, okay, and you got pmv dot plot bc ghb plt dot color bar pc, okay. And this is the boundary conditions, okay. And well, there is an issue with the color. Yeah, by default, it's only showing the values on the layer one. Okay. Yeah. Okay. If you are here with me, please type 8. Okay, great. So okay, so let's continue. So now let's work with the observation, because what we want is that on the observations you have what we want is that on the observations you can represent the tide. Okay, so let's say, so ops path is equal to os dot path dot join of os path dot I use this sim path. Okay, I use all of this because sometimes the Flowpy cannot reach the file. Okay, so this is model one dot op. Yeah, this is a, I mean, I usually I use an, I I work with a relative path, but when I find some errors, I have to work with the, I have to work with the OS package. Okay, it's not my first option. Okay, and it looks ugly, but this is how it works. Okay, so it's a flowpy.utils dot observation file, and okay, so this is mf6 obs of obspat. Okay, so we can, okay, so now we have, okay, and this was uh and I know that, okay, this was for new for me because I never worked with observation file in Modflow 6. So but we can go with gwops.getops names. Okay, great. And so these are all the piezometers there. If you are here with me, please type 9. If you, okay. Okay, for the people that won't be at the end of the session, okay, the recording will be, okay, the link of the recording will be distributed at the end of the session. For the people that has to leave and want to access to it, this will be on our Patreon. So if you want to support us through Patreon, okay, all our former webinars are there. Okay, so this one and the maybe 30 more webinars will be there. Okay, great. So let's see about the times. GWF times. So GWF ops dot get times. Okay, GWF times. Okay, let's see the first 5 times. Okay, these are the first 5 times. And then here the times of the observation are according to the stress periods. Okay, great. So GWF ops df is equal to PD dot data frame dot from records GWF ops get data set index. Okay, so we import that as a, okay, and then we since we are working in seconds, okay, we want to that the index will be in fraction of a day, just to make it more. Ops df index is equal to ops df index divided by, okay, okay, so this will be our, okay, so now we have fraction of a day, and this will be better for the, okay, and now we open as well the TIDF again because but we open that as a as a text file. Text and day header is equal to none. Index call is equal to 0. TIDF is equal to TIDF dot TIDF dot index is less equal to TIDF columns is equal to tide elevation. So we change the name of the column. And then we also change it to TIDF dot index. We change it to fraction of a day. So we have the head, and this is the observed values of our tides. Okay. Columns. Okay, great, great. So let's do the plot, the magic. Let's do the magic. Okay, so let's plot, okay, our tides with the response on the different observation points. Okay, this is what you want. or this is what I would want if I attend to this. Fix x is equal to plt dot subplots. Okay, but before I'm doing this, okay, I would like that you introduce yourself because uh, with your name, well, not your name, but for example, I will introduce myself. So my name is Saul Montoya. I am hydrogeologist, hydrogeologist, okay, and my level of Python is advanced, and I am from Peru. Okay, so please introduce yourself. Okay, and then plt.plot of gwf ops df label is equal to gwf ops df dot columns line weight is equal to 0.8 plt dot plot of type df label is equal to type df columns of 0 line weight is 2 plt dot legend. Okay, plt dot grid. Great, Vitor. Okay, for the rest of the people, please introduce yourself. I have seen you from some people from previous webinars. So, well, it's nice to it's nice to see you. I mean, I really take notice that you participate on the that you really that you participate on all these events, and yeah, because you give your time for this, and it's much appreciated. Your level of elevation on meters above sea level. Okay, so and then we see plt.show, plt.show. Okay, so well, let's see. And this is amazing, this graphic. Okay, yes, this graph. Okay, so we see the tides, okay, and then we see the impact on the, I mean, okay, great. Uh, Luis Solis has shared his, okay, great, Marta. For example, Lester is from Canada. Erin is from South Africa with no Python experience. Galmuti is from Cameroon, and Victor and Luis is from Spain. Great. Radha from India. Okay, great. So, okay, so what we see is that okay, what we expect is that okay, these two are from, uh, these two are the closest ones, okay, and these are the farther one, okay, and then as long as the values are far from the sea, okay, they will have less response. When these are closer to the sea, these will have more response. And then here you see that maybe 1 hour is too low because the curve is not that accurate. I mean, and that depends if you have and that depends if you have more data or not. I mean, because here, if you have well-defined data, okay, so it will be worth maybe to use every half an hour, but that is really up to you. Okay, so that is the result of this modeling. It's quite interesting and for me it's quite advanced. And thank you for being here. If you have any questions, let me know. Okay, great. So I will stop the recording.